Hey guys, welcome back to our segment routing traffic engineering series. In the last episode, we kind of went ahead and did, quite a bit of hands-on, and that we kind of logically concluded one part of our hands-on that was mostly around creating dynamic SRT policies, and we explored different type of path calculation which were done by your head-end node, or which we were calling the PCC also. So we had looked up IGP, TE, hop count, and latency or delay as different type of metric for our path calculation from our head-end node to our endpoint, which happens to be our destination or tail end endpoint. So there was one thing common across all of those hands-on, that the policy that we were configuring those policy on the head end or PCC, and we had left the path calculation work to be carried out by that particular head end or PCC. We're going to go ahead and continue based on that, and we're going to go ahead and explore few other concepts in this particular theoretical concept, and then we will again jump back into the hands-on. So before we really need to understand SR-PCE, we need to understand a few more things. Again, I am referencing the material available on segment-routing.net. Thanks to these guys for putting such a wonderful material. All credit goes to these guys. So before we kind of understand the SR-PCE, we need to understand that there is something in the dynamic path. There is something called distributed, and there is something centralized. So let's take a look at what is distributed and what is centralized really means. So there are two possibilities to compute the dynamic path for an SR policy. In one of the first cases, the head end computes the path itself, and that's what we have been primarily doing in the past hands-on, where our head end node, which is also called PCC, was the one which was computing the path itself. And in that case, this is called distributed model. We have another type which is called centralized. In this, the head end request. So in this case, the head end will be requesting some entity, and that entity is named as SR-PCE to compute the path. That means the path computation work is being offloaded to some other element or some other router in the network topology, and that particular router name is called SR-PCE basically. Now by default, dynamic paths are computed by the head end, and that's what we had seen, and that's what we were doing in our past hands-on, that whenever we created a policy, our head end was responsible for calculating or computing the path from a source node, in this case happens to be the head end node, to our endpoint, which happens to be our destination. Head end, in this case, head end uses SR-PCE, which is again a dedicated router. When local computation is not possible for whatever reason, if the head end is not able to compute a path itself, then it can go ahead and get an help of a dedicated router which is acting as an SR-PCE, or it can always ask SR-PCE to help to compute a path from a given source to a given destination. So SR-PCE is required if more information is needed than is available on a head end. Example, like you have multiple areas, you have multiple domains, you have multiple paths, or you want to take disjoint path from different head ends. So these are some of the other things that makes SR-PCE really pretty interesting for the segment routing. And that's what we're going to go ahead and explore some of the more things in details here. So head end and SR-PCE, same algorithm. They pretty much run the same algorithm. Head end and your SR-PCE. So head end mean your PCC device, and SR-PCE in short is called PCE. They primarily use the same algorithm, which is SR optimized computation algorithm. The only difference, decentralized versus distributed. And again, with the SR-PCE, you can do a little bit more, and we will see some of those things as we go ahead and explore. Yeah, you can take a look at all of these slide deck to understand a little bit in more details. So let's spend some time. What is SR-PCE? So as the name says, SR-PCE is segment routing path computation element. So a lot of people, in just short, it's called PCE, path computation element also. And your PCC, which is your head end, also called path computation client. So this is path computation element, and your head end node is path computation client. So SR-PCE is an iOS XR multi-domain stateful SR optimized PCE. That means iOS XR SR-PCE functionality is available on any physical or virtual iOS XR node. So that means as long as you have access to a virtual or a physical iOS XR device, you can have that device acting as a SR-PCE within your network. It really helps when you have multi-domain. So it's a real-time reactive feed via BGP-lS, and that's what we had seen, or with one of your IGP protocol is feeding that information. Another great thing about SR-PCE, it is stateful. So that means takes controls of SRTE policy, update them when required. So it is keeping a full state of your network. With that, it also kind of might bring up some challenges. As the network is growing, one SR-PCE might not be enough. You might have to bring up 2 SR-PCEs or multiple SR-PCEs. And again, SR-PCE is fundamentally distributed. So not a single all overseeing entity primarily. So the whole idea behind the SR-PCE, we'll have a dedicated router or a device which is keeping a track of all of our network topology, keeping a track of the state, and with that, it can go ahead and we can make use of those state inside our SRTE policies primarily. So your SR-PCE, IOXR-PCE, so just to simply turn on the SR-PCE functionality on any of your iOS XR box, you would just need to go to the box and say PCEA. I'm turning on the PCE capability on this device. And then you need to go ahead and provide the IP address of your PCE server or PCE node. And in that case, it could be the loopback IP address or any IP address that becomes reachable. So what really happens while doing this? Enabling it by configuring its PCEP. So now your PCC or the head end can talk to your PCE over the PCEP protocol, and over the PCEP protocol your PCC can ask your PCE to do path computation, and over the same link the PCE can go ahead and provide that path back to PCC. So that's pretty simple in terms of the configuration that needs to be done. Again, your SR-PCE will learn the topology again via either from BGP-lS or from your IGP. BGP-lS is intended to carry link state topology information, and LS stands for simply the link state. So that's why when we say LSP, these are link state protocol primarily. BGP-lS has been extended multiple times in order to incorporate, because from BGP we saw there was a variation of MP-BGP, and then we have this BGP-lS. So this can go ahead and carry some more information, the topological information for you, like SR extension, traffic engineering metrics extension, egress peer engineering, SRTE policy. And again, all these information is being fed to SR-PCE via either your IGP or your BGP. So in case of BGP, it is called BGP-lS, and LS stands for simply the link state. Again, as usual, there is an SRTE database. So SR-PCE uses the same multi-domain SRTE database as the head end. SR-PCE can learn and attach domain topology via its IGP or BGP-lS, and it is pretty much the same command. If you have multiple instances, when you are doing a redistribute, that means when you are feeding the IG information into SRTE database, we can go ahead and associate an instance ID. That way it helps to identify multiple domains easily. So if you take a look at this particular example, in this case there are, we have coupled domains. So to identify these domains to SR-PCE, when we are distributing the link state, we can go ahead and something called an instance ID. So in this case, I can say, hey, this is my instance ID 1, this is instance ID 2, this is instance ID 3. That way, so when any kind of update comes in, SR-PCE knows, okay, hey, this update is coming from domain 1, and it needs to go into domain 2 and some of the other information. So for that, the only thing that we have to do, we had learned this distribute link state. Now you can go ahead and do instance ID 32, or matter of fact, any number. And again, this is only needed if you are dealing with multiple domains. If you have single domain, you don't have to do any instance ID. You can just leave it like the way we have been primarily doing. Now, same multi-domain SRTE database. So in this case, that's what we are looking example. Router ISIs, we are saying, hey, distribute link state, we are giving an instance ID in that particular case. That is the only thing here we are saying, okay. And now if I go ahead, and again, you can go ahead and read through these slide a little bit in more detail, and this kind of says, okay, SR-PCE uses this complete topology. Now this topology came to SR-PCE from BGP-lS or from your IGP, and using that information, it can go ahead and do any path computation for us. And another thing, if you just recall, it is stateful also. It is keeping a track of the state in the network. As things changes, it will go ahead and update its SRTE database. Now here it just says, okay, hey, BGP-LS is being fed to SR-PCE. Typically BGP-RRs, which happens to be route reflectors, are used to scale BGP-LS feeds. So all of the typical devices probably go ahead and neighbor with your RR, and your RR will have SR-PCE as the neighbor. So that means whatever these RR are learning from the network, they'll go ahead and feed that information over BGP-LS. So the RR and PCE will have a BGP neighborship over the link state address family. I mean this particular address family link state, which is your LS address family. And on that, it will go ahead and share the BGP-LS from the RR to PCE. That way PCE will have the end-to-end network topology, and it will use that to do any kind of a path computation or path calculation from a given node to the another node. Again, that's what it just talks about, the same thing what we went through. SR-PCE receive topology of all domains. Each domain feeds its topology to SR-PCE via BGP-LS again. Okay, it will go ahead and consolidate everything on the SR-PCE. Multiple domains, we just saw that. Okay, hey, when you are configuring your IGP, now you can go ahead and append an instance ID. In this case, we are feeding 2 IGP domains to our SR-PCE. One is marked with an instance ID of 32, another with an instance ID of 33. And these needs to be unique as what it says. So you can go ahead and do that. And pretty much that's what it looks like. A lot of things are common. Now, if you see here, MPLS traffic engineering loop common T router ID. So in this case, the router ID is common. That's what it says. And because this belongs to domain 1, this belongs to domain 2. And that's how the SR-PCE will kind of differentiate based on the domain IDs. Okay, and this is T router ID equals to BGP RID. And again, that's what we just went through, that SR-PCE primarily uses the same SR optimized computation algorithm as the head end. But now instead of head end doing the whole heavy lifting, we have offloaded that work to another component or another router in the domain, and that router is your SR-PCE. Now your SR-PCE computes dynamic path. A head end requests SR-PCE. So what happens? A head end requests SR-PCE to compute a dynamic path. Request, reply, report, or report, update, report workflow is used. And we will go ahead and do some more configuration, and that's where we'll take a look at. So SR-PCE is stateful. It maintains the path, updates the path whenever required, means whenever there is a topology change, like a router going down, a router coming up, a link going down, a link coming up. So those are all the changes, and as the change happens, SR-PCE will also go ahead and update its SRTE database. Now SRTE computes dynamic. So we saw there is a request, reply, and report workflows involved. So head end is kind of a request. So it is using a request report. Head end request SR-PCE to compute a path. So head end provides optimization objective. So that means we'll go ahead and provide the optimization objective. And what are optimization objective, guys? Yes, like TE, IGP, delay. All those are your optimization objective, as well as we can also go ahead and add something called constraint that we'll go ahead and learn. Constraint were the conditions. Hey, go ahead and pick this path versus over that path. I don't want you to take this particular link or that particular node. All those are constrained. So that means your head end node can send this optimization objective as well as constraint to SR-PCE, and then SR-PCE computes path. It drives a SID list and replies to head end. So it will figure it out a path based on this optimization objective and based on these constraints. And once it has a path from that given source to a given destination, it will go ahead and give that SID list, and that information or that workflow is called simply a replies. So it replies to the head end. So once the replies goes to the head end, now the head end programs this received SID list from SR-PCE and reports it to SR-PCE. Okay, hey, I have went ahead and programmed this SID list, and I'm reporting you this new status. Why is it reporting the status? Because SR-PCE keeping a track of the topology. So now there is a change happened, and that change is being reported by this head end to the SR-PCE. So SR-PCE will go ahead and update this SRTE database. Now it knows, okay, hey, there is an active policy from this head end to a given endpoint. So if there is any change happens, SR-PCE will go ahead and update its database accordingly. Now the head end delegates the path to SR-PCE. So that's what in this case is happening, that the path delegation is being given to SR-PCE. Pretty much the similar example kind of flow continues. So report, update, report workflow. So in this case, it's the update is happening. Headend reports empty path to SR-PCE. There is no path initially. Headend delegates the path to SR-PCE. Headend provide all again optimization objective and constraint to SR-PCE. SR-PCE will go ahead and compute the path. It drives a SID list and it's going to update this time path on headend, because headend already had a path and which happens to be an empty path actually. Now the headend programmed this SID list and it will go ahead and report the same thing to the SR-PCE. So this is an example of update. And anytime you see these things, these are called reports, guys. So there is a report, there is an update report, there is a report. So these are called simply the report. So your headend, whenever there is anything happens, it reports all of these things to PCE. That's why we just call them reports, all different type of reports. And that's what it just says again, request, replay and report workflow. Again, you can, read about these, some of the things again in detail. I would highly encourage you guys spend, some time and go through some of the things. Just to go over again, SR-PCE is stateful. That means SR-PCE stores path computation requests, which are stateful. Request includes optimization objective and constraint. So it keeps a track of all of the optimization objective as well as constraint. SR-PCE has control over the path delegated to it. That means if SR-PCE, let's say initially SR-PCE gave a path via, let's say node A, B, and D. And let's say there is something happens to node B. So now because the path was calculated by SR-PCE, it keeps a track of the network, and let's say node B went down and node C came in place of B. Now it can go ahead and recalculate that path and give that path, new path to the headend. So it kind of delegates to it. SR-PCE updates the path when required. Example, following a multiple domain topology. That's what we kind of noticed here. And these are again the example of SR-PCE update path. I would highly again encourage you to spend some time, read some of these examples. These are pretty cool examples. SR-PCE update path. And then again, SR-PCE can have its high availability. That means again, just to provide a high availability, we can have more than one SR-PCE or a pair of SR-PCE. That way one goes down, second will take over. SR-PCE leverage a well-known standard PCE architecture or HA. Headend sends PCEP. Now remember, PCEP is the protocol that runs between your PCC and your PCE. So headend sends PCEP reports for SR policy to all connected SR-PCE nodes. So that means if you have two nodes of SR-PCE, your headend will send the same report to both of the nodes. Headend delegates control to primary SR-PCE. When you have a pair of SR-PCE, the very first SR-PCE, whatever, if you guys call it, either you can call it the primary, master, or active. So whatever is your primary or active or master SR-PCE, when you look at the policy, it will have a flag by D. The D indicates a delegated flag, and it will report, hey, whichever is your primary SR-PCE. So delegated flag is set in PCR report to primary SR-PCE. Whenever the report is sent, you will see this D flag, and we will see that during hands-on, so don't worry. This is a way to say, okay, hey, out of these two SR-PCE, which is the SR-PCE is the one which is delegating or controlling, the path computation for this headend. And we'll go ahead and take a look again hands-on. Upon failure, if there is a failure happens of the primary SR-PCE, headend redelegates control to another SR-PCE, means the second SR-PCE will take over. So that way, we always maintain some of these things. And it talks about again, SR-PCE is fundamentally distributed. SR-PCE not to be considered as a single all overseeing device. SR-PCE deployment is closer to kind of a BGP-RR deployment model. Different service endpoint can use different pair of SR-PCE. Choice of SR-PCE can either be based on proximity or services. Again, this talks about fundamentally how it is distributed. Just comparing with the RR. And now it's talking about some of the use cases. So we will go ahead and, talk about these use cases during our hands-on. But so far, what I want you guys to take away from this particular session that, okay, hey, so far we have been doing the calculation for the path computation locally on the headend nodes for our dynamic policies. Now we are going to introduce a dedicated route or a component which is called SR-PCE. That will help us do the path computation from a given endpoint to a given destination. And this becomes pretty handy and very, very useful when you have a large scale network, because you have multiple domains, multiple areas. and that way you can have a pair of SR-PCE running which can see overall topology and do all the path computation based on certain optimization objective as well as including some constraint. In certain scenarios, doing a path calculation on head end locally is not really helpful, and we'll go ahead and explore those as we progress in this series during the hands-on. So that'll be all for this episode. I will see you guys in the next episode. Again, you can go ahead and download this material from segment-routing.net. I'm just referencing the same material. I'm just reading it out for you guys to make it easy. And then we will follow this with the hands-on actually. So that'll be all. Thank you for now. Bye-bye.